Okay, as promised, I am recording, working through the check your understanding questions for sampling distributions from Mathematic, so that as you work through and check yourself on what we learned today in class, you will be good to go, or at least have your questions answered. All right, so I'm going to turn the video off and get to work in just a second. All right. So checking your understanding for each scenario, identify the population, parameter, sample, and statistic. Use correct notation for the parameter and statistic. Gallup organization recently interviewed a random sample. Boom, that means right here, I've got my sample. Notice I love annotating, it helps a lot. Adults in the US. So we've got a population here of adults in the US. And asked them their annual income their family needed to get by. The average amount for the sample was $85,000. Okay, so sample, this is the 1,013 adults in the US. Corresponding to that, the statistic, the average, the sample mean, X bar, is equal to $85,000. Whereas I'm going to use something other than this red later. On the other hand, we have a population of all adults in the US. And then the parameter would be the true mean annual income needed for families to get by. Um, and I guess I should say then that the statistic is the mean annual income needed for families to get by in the sample. I'm gonna be right back for 1 second to check one detail. I forgot to put mu here. Okay, so part B, the Gallup organization recently interviewed a random sample of 1,013 adults in the United States and asked them how much annual income their families needed to get by. The standard deviation amount was 15,300. Okay, so same sample, same population. So my sample is the 1,013 adults in the US, whereas the population is all adults in the US. Now, this is where you need to pay attention because they're asking for standard deviation, or in the parameter, it's standard deviation this time. So it's sigma, the true standard deviation of income. One thing you may want to be aware of is standard deviation is often abbreviated SD. And the statistic is S equal to 15,300. All right, part C. Some curious AP statistics students believe that the most cars in the school parking lot are silver. They take a random sample of 30 cars in the school parking lot. So sample is 30 cars in school parking lot. And so the statistic is p hat of 0.36. And then the population would just be all cars in school parking lot. And then the parameter P would be 0.36. Nope. Man, that's what I get for being distracted. P is the true proportion of silver cars. All right, number 5, students wanted to estimate the average word length for Beyonce's song Crazy in Love. Each student takes a random sample of 5 words and calculated the mean of the sample. Then they used all the sample means to create a dot plot. Does this dot plot represent a population distribution or part of a sampling distribution? Do note they said part here is not a full sampling distribution because it is not the collection of all combinations of uh, samples of 5 words. So it is a part of a sampling distribution and is a part of a sampling distribution because each data point represents a statistic from a sample. Notice these are all little X bars. Not sure if you can actually see that, but there's check your understanding for that first lesson we did today. Check your understanding for the second set. So the James family has 5 children: Jocelyn, age 8, Elise, age 8, Michael, age 14, Erica, age 16, and Sarah, age 18. Complete the table by listing the 10 possible samples of size n equals 2 from this population. Calculate the sample mean age for each sample. So we got Jocelyn and Elise. We've got Jocelyn and Michael, Jocelyn and Erica, Jocelyn and Sarah. Now we're going to do Elise with everybody. Now we already have Elise with Jocelyn, so it's going to be Elise and Michael, Elise and Erica, and Elise and Sarah. Now we've got Michael with Erica, Michael with Sarah, and Erica with Sarah. Notice this is the same as the sample space that we studied last unit in probability. But the average age for each of these would then be 11, 12, and 13. Hopefully I'm not making any mistakes here. And so these would all actually be the same. And 15. Michael and Sarah would be 16. And then 17. So sampling distribution of the sample mean age of samples of size 2. So we've got 1 dot at 8, Typically we use dots. I'm going to use the X bar to drive the point home that this is, in fact, a sampling distribution. But yes, it is a dot plot. I am aware of this. I am just trying to drive home a point. Alrighty. And so I've got, I gotta check my tools. I don't have a title yet. All right, so I've got title, I've got units, I've got labels, and I've got a scale. We're good. What is the mean of the sampling distribution of the sample mean? What is the mean of the population? Okay, so the mean of the sampling distribution. So that'd be 8 plus 11 plus 12 plus 13 plus 11 plus 12 plus 13 plus 15 plus 16 plus 17, all divided by 10. Which would just come out to be 12.8. So this would be the average. So notice I'm using mu because it is a population. It's the population mean of all the sample means. Whereas the population mean, again, notice I'm using mu because I am dealing with a population. Elise, or no, that would be Jocelyn, Elise, Michael, Erica, and Sarah. That is also 12.8 years. Is the sample mean an unbiased estimator of the population mean? Well, mu sub x bar does in fact equal mu, so the sample mean is unbiased while estimating mu. Suppose we had taken samples of size 3 instead of size 2. Would the variability of the sampling distribution of the sample mean be larger, smaller, or about the same? Well, as we learned today, as the sample size increases, the spread slash variability decreases. And done. All right, hope you use this video, and I shall see you in class tomorrow.